Hello and welcome back to the course on blockchain. And today we're talking about segregated witness, SegWit. You may have heard this term, and today we're going to get like a brief overview of what it's all about. We're not going to go into the technical details behind it, but briefly we'll discuss what SegWit is all about, why it's important, and so that you're prepared for these conversations if you ever need to have them. Alright, so let's have a look. This is our block. And block 500,112. It's just a made-up block, of course. And as you can see, it's got quite a few things inside this block. It's got the block number, timestamp, nonce, previous hash, and so on. There's actually a couple of other things, and all of those are called the block header combined, because they are not the transactions. They're not the actual contents. They are just like a something that goes along with the block, additional information. Whereas the transaction, that's the main body of the block, the transactions. And so in Bitcoin, there's a limit. There's a limit to 1 megabyte for the size of the block. And this was included in the original design. There's speculations about the reasons for that. And probably one of the main ones is that if you have a block size which is too small, then you can't include too many transactions in it. And therefore, you're going to have like a lot of bandwidth problems in the network. People are going to be waiting for too long to include their transactions. On the other hand, if you make the block size too large, then the network is going to be slow, because remember, the whole ledger has to be shared with the whole network. Everybody has to have a copy of the blockchain, and therefore, whenever a new block comes along, it has to be copied to all the computers around the world. And if it's too large, then that will take a lot of time. So if it's like a 100 megabyte block, that will take a lot of time for it to go through the network, and that means there's going to be more chances of orphaned blocks, more chances of competing chains, and more chances for attackers to take advantage of the blockchain and do something, because information is propagating so slowly, and they'll have more time to do that. So the middle ground is decided to be 1 megabyte, but and the Bitcoin blockchain has been working good with it, but recently it's been towards people have been noticing, like last year in 2017, people have been noticing that it's been slow, and sometimes there've been transaction backlogs, and so they try to solve the problem. How can we solve this problem? How can we get more bandwidth in the network? And there's a couple of options. There's a approach of a hard fork and a soft fork, and we'll talk about more about forks in module 3 of the course. Well, the hard fork that was proposed was to increase the block size, and the soft fork was segregated witness. And so there's two different approaches, and basically the hard fork, eventually that's what resulted in Bitcoin Cash that we see now, but we'll talk about that more in module 3. The soft fork was segregated witness, and what does that mean? Well, a soft fork is like an upgrade to how the blockchain works, which is not compulsory for everybody to take on board right away. It can propagate over the network with time, and people can accept it slowly, so it's easier on the network that way. And so what segregated witness does is it looks at the contents of an individual transaction. So here's our transaction. And as we discussed previously, and this is why this tutorial fits in well here, because now we know about transactions, not only how they work, but actually we know about signatures and public keys and private keys and verifications and things like that. And so we know that a transaction is not as simple as just the header, the number of the transaction. It's actually got more to it. It's got of course, the from, to, and amount. That's the main reason for the transaction. We need to know who we want to add to the chain, who's sending whom money, and how much money they're sending. But also, for security purposes, we cannot just include that information. We cannot just put their names there. We have to put their addresses, and also we need to put a signature and a public key. We need to attach our signature and our public key to the transaction. And the reason for that is because we need the nodes to be able to verify who has signed the transaction, and has it been signed by the person who actually holds the private key behind that public key. And this is all good and well, but the issue is that this signature and public key, as we could see, they're huge numbers. Transactions don't necessarily have to be that large. It's just, one address, another address, and the amount. Whereas the signature, you can see it's like a massive hexadecimal number, and the public key is also a massive hexadecimal number. So they end up taking up to 60% of the whole transaction size. And yet they're not the main purpose for the transaction. They're just another way for, like a verification, a security mechanism, but they take up so much space. So what was proposed was to take this part of the message, this heavy part, which is also called the script sig, and remove it from the message, strip it out of the message, and send it as its own, through its own messaging service and on the network. So it will still be linked to each block and each transaction, but it will go through the network separately. And that way we save some space. That way each one of these transactions reduces substantially in size, and we can fit in more transactions. And the key thing here is that you might hear that the SegWit increased because the SegWit was adopted by the blockchain network on the 24th of August 2017, and slowly started seeing more and more nodes uptake SegWit type of blocks being sent around. And the thing is, because it's soft fork, it's backward compatible, meaning that even nodes that didn't accept SegWit, they still participate and everything is working fine. So what you might hear is that SegWit increased the block size to 204 megabytes. Well, that's not true. The way to think about it, technically it's not true. The block size is still 1 megabyte. It's not going to change. It requires a hard fork to change that, and the result, you end up with something like Bitcoin Cash. You might have a split in the network if you want that to happen. Again, we'll talk about forks further down in the course, but if that's not something that you can change easily, it's still 1 megabyte. What people mean when they say that the block size increased, and I'm doing floating quotation marks here with my fingers, the block size increased to 2 megabytes, is what they're saying is that now you can include, where you could include previously, you limited to 1 megabyte of data. Now you can include a lot more data, which feels like 2 megabytes of data, right? Feels like 2 megabytes of data. But at the same time, because these things are getting stripped, and it's about 60%, so even more, if you can even include a bit more than what feels like 2. People say like it can get up to 4 megabytes. But the point is, like, in comparison to what you had previously, if you're including X transactions previously, now you can include like more than 2X transactions. So it's as if you're including 2 megabytes of data in the block, but in reality, this part is getting stripped out and is being sent separately. So in the end, you're just ending up with still 1 megabyte of data in the block, just more transactions. So there we go. That's how SegWit, like a general overview of SegWit, so you know what it is. Oh, and by the way, why is it called SegWit? Because witness, this data, witness is a synonym, is used as a synonym for signature. So it's a segregated signature. You can say that, but sig I guess doesn't sound that great. So segregated witness meaning that you're segregating this block, you're segregating the script sig into its own messaging channel. That's why it's called SegWit. And hopefully now you're prepared for these conversations, a bit more information about how the current blockchain, how the current Bitcoin blockchain is structured. By the way, it's not just Bitcoin. There's a couple of other cryptocurrencies like Litecoin who use SegWit because it increases network throughput, it increases speed. And the bottom line here is that Bitcoin and blockchains, cryptocurrencies have great advantages, but one of their main disadvantages is that they're slow, is that their throughput is slow. Like Bitcoin right now is about like 10 transactions per second if you average it out, whereas things like Visa and MasterCard, they go up to tens and hundreds of thousands of transactions per second. As we know, everybody's using cards and so on. They have a massive throughput. So if Bitcoin and cryptocurrencies are going to compete with players like that, then they have to solve problems of latency. Well, it's not more latency, it's throughput problems like this. And so SegWit is one step towards that, but there's lots more steps to be taken. And lots more decisions to be made in the future of Bitcoin and other cryptocurrencies in order for them to have that throughput that will be like that can compete with what we have with the banking system that we have right now. So there we go. Hope that makes it a bit clearer what SegWit is. For additional reading, I'll redirect you to the legendary, as they call him, Jimmy Song. So Jimmy Song is a developer of blockchain, I think maybe even Bitcoin, not sure about that last part. But basically, he has, like, I haven't read that many things from Jimmy Song, but they are quite well written. And also, I've heard quite a lot of people say good things about him, and that like a lot of influencers in the space of cryptocurrency always kind of reference Jimmy Song for his knowledge, for the things that he shares, and they say listen to Jimmy Song. He knows what he's talking about. He knows these things. So he's got an article on Medium called "Understanding SegWit Block Size." I will say his style is not very it's a bit technical. It's not completely simple. So you will find it's not that easy over read. It's not like extremely programming and technical, but he uses terms that might be quite hard to grasp, so be prepared for that. But at the same time, it does explain a bit more details about SegWit than what we had here. But even what we had here is enough to get you started on understanding SegWit. This is if you want to go into more technical things and understand like exactly how, or more closely how things will work in that technical side of blockchain. All right, so there we go. That's us for today. Hope you enjoyed the tutorial, and I look forward to seeing you back here next time. Until then, enjoy blockchains.